Wanted to share a couple different ways that you could make threads in Fusion 360 for 3D printing. I'll start this by saying I'm not the only one with videos on this topic. There's quite a few of them on YouTube, so don't take this as like a full, extensive, and conclusive way to build threads, because there is a number of different ways to achieve this in Fusion 360. I'm just going to share some of the techniques that I have found to be pretty useful. I know that making threads can be a little intimidating. I know it was for me for a while, especially coming from other tools like Blender and Maya and Cinema 4D that were not CAD-based tools. Working with CAD software on its own can be a bit of a challenge. So let's dive in here. Let's take a look at these two threaded bits we have here. So I've got a female on each and I've got a male on each, but these were constructed very differently, and obviously they look very differently. One looks more traditional on the left hand side, and then on the right this is not as traditional, I guess, if you consider hardware like screws that you would work with, machine screws, right, or like metric based screws that we use a lot in 3D printing. This is a completely custom thread, and it's because it's using a cord. The one on the left is just simply using the built-in thread tool in Fusion 360. So if I turn on the analysis here, you can see that they both have tolerances. The cool thing with the thread tool is it will automatically apply a tolerance for you. So the left, I really didn't have to do much. I applied a thread to the screw, I applied a thread to the female, and boom, there we go. And I believe it applies around a 0.15 millimeter tolerance here, and in Fusion 360 we can actually measure this real quick. If we go up to the inspect and we hit measure, I'm going to measure the outside and the inside, and it looks like we have here 0.174. So that's very reasonable for most 3D printers. If you're using a bamboo, generally 0.12 is a pretty tight thread, and then 0.14, you can even go up to 0.15, is going to be a little bit looser. That's what I found on my X1 Carbon as well as the A1, but they're going to vary by printer. I know some folks go up to 0.2, and evidently some folks are even going to 0.3 on some of the NE cubics. So the one on the right here required more work, but it's a lot more customizable because I've used a cord to achieve this. But again, here I've set an offset here, and this one specifically is 0.14 millimeters. So let's look at how these are constructed, and we'll start from scratch. All right, I'm not going to do a full rundown of the Fusion 360 interface. There's a bunch of great videos out there that can be found on the interwebs to help with foundations in Fusion, but I will touch on just a few basic things. So I'm going to go up and I'm going to create a sketch by hitting the sketch button in the upper left corner. It's asking me which plane I want to draw it on. I'm going to draw it on the floor, and then I'm going to go up and grab a circle, and I'm going to draw out a 10 millimeter diameter for my circle. I'm also going to draw another circle over here because we're going to do a little bit of a comparison here. I'm going to make that 10 millimeters as well. Then I'm going to use the offset, so I'm going to hit the O key. Going to offset this 3 millimeters, going to offset this 3 millimeters, and I'm going to hit finish sketch. So now we have our basic shapes down on the canvas. So first I'm going to extrude both of these up by selecting them and hitting the E key. All right, we got 15 millimeters. And so I've got analysis on right now, which is why this is cut in half. This is really helpful for checking tolerances and being able to see through pieces as far as how they're matching up. Sometimes you're not able to see that, and an example would be, let's go ahead and extrude our female part, and note that I'm only selecting the outer ring, if you will. I'm not selecting this whole object. Let me turn off these bodies. I'm only selecting the ring on the outside. So let's select these two. Let's go E, and let's say like 5 millimeters. I've got to turn the bodies folder back on. Okay, so here I can't really see inside where the male and the female are kind of matching up, but if I turn on section analysis, you can see there we have it. And I'm also noticing, this is a dead giveaway, that When I extruded the outer part, I selected join. So this is the great thing with Fusion 360. I can go back in my parametric timeline, can go over here to the right and see where it says operation. I'm going to change that to new body. I'm going to hit OK. Now we can see there's an actual line here, a separation, and that's clearly indicating to us that these are separate bodies. You can also see that in the browser on the left-hand side. Okay, so how do you enable section analysis? Pretty easy. Go up to inspect, go down to section analysis, click on it, and it's just going to ask you the plane that you want your section analysis to be on, and you click it, and then you'll end up with a folder on your left that is called analysis, and to use it, you just literally turn the folder on and off. And you can also edit the section analysis by just right-clicking on it, hitting edit. You could rotate it, like if this is not the side that I wanted to see, or I wanted to have like an interesting angular cutaway, this is how you would go about doing that. So when you're creating threads, very, very helpful. Okay, so the threads themselves. If we go up to create and we click on thread, and I select one of my bodies, I'm going to turn off analysis here, you'll notice that it just created a thread for us. And it has thread profiles up here under thread type, which are, I believe these are like industry standard thread profiles. And what it's going to attempt to do is give you the right thread given the diameter of the object that you just applied it to. But in order for this to actually work for 3D printing, you got to tick this box that says modeled. As soon as you do that, you can see now we've got a nice modeled thread. So we'll just hit OK. So that wasn't too bad at all. Let's turn on our analysis here. You can see there we go. We've got these nice threads. So let's do the female side. So what I'm going to do here is I'm going to turn off that body just to make it easier to select it. I'm going to select the cavity in here, and I'm going to go up to create thread. And because that cavity is the same diameter as the actual screw bit itself, there you go. Now, I have noticed sometimes, and I don't know why this is, when I have complicated models and I've got lots of separate components going, which components is a very different discussion, that sometimes the threads don't match up the way they are right here. Like this is going to work, that's fine. And this is totally 3D printable. This is going to have like a 0.17 offset, or I'm sorry, tolerance here. Let's look at using a chord to achieve something similar. All right, I'm going to hide the bottom, and we're going to go up to create, and we're going to choose, or I'm sorry, I've been using the wrong term the whole time. It's called a coil, and we're going to use a coil. And the first thing that you're going to need to do with a coil is you're going to need to select the plane on which you want this to, or I'm sorry, the geometry, or the profile that you want it to work on. And you can turn off your sketches here, and I'm going to select the bottom here of my object, and next it's asking me for the center point. So I'm going to select the center point, and then I'm going to drag it out, and I'm basically going to drag this out to the same dimension, which is 10 millimeter. You can go bigger, you can go smaller, but I'm just going to go right to the edge. And it just made a coil for us, but it's in the wrong direction, and the diameter of the cord is a little bit off. So let's make some of those changes, and it's a little bit easier to use the editor on the right hand side. So for the section size, maybe we want this to be like 2 millimeters, and then the height, we need it to go the other way, so we're going to say minus, actually I think the height of this was 15, so we're going to go minus 15. And then the revolutions, you can choose revolutions. Maybe we don't want this to be a super densely packed thread, so I'll just hit 3. And right now it's doing a cut command, and that's because down here the operation is cut. But if we go join, it's going to add it to it. And don't worry, it's going a little off the top and the bottom. This is normal for using a coil to achieve this, but we can use some simple tools to clean that up. And then you also have some other adjustments here. I'm going to turn on analysis again so you can see this. Section on center, section inside, section outside. You can also change this to a triangle. Triangles actually work really well. I've used this more than the round for creating custom threads. And again, you could move this inside, you could have it on the center, but for a triangle, having it on the outside works really well. So let's say that we're happy with our thread right here. Now, if this was going to be 3D printed, we probably wouldn't want this sharp of an edge, and there's an easy way to fix this. So you just select the edge, we can go up here to press pull, Let's offset that like 0.2, and it's just going to push it in. And what that did is it just created a little bit of a fillet for us and made that a little bit rounded off so it's not super sharp and thin, which can sometimes be problematic with 3D printing. The other good thing about this is it is perfectly, the angle here is totally sufficient for a 3D printer to do this without supports. Actually, both of these are. Next, let's do some cleanup on our thread to actually make it look a little bit more like a thread. So we're going to turn off section analysis. And now what I'm going to do is I'm going to go into either the front or the back view, and I'm going to go create a new sketch. And it's asking me for the plane. If I turn off my bodies, you can see here I can just click this plane. So now we're on our front plane, and I'm just going to draw out a couple rectangles, and we can snap this to the existing geometry and drag it over and just drag it down like that. I'm going to do the same to the top. I'm going to go over here, drag it over, drag it up, and I'm going to hit finish sketch. Okay, the sketches hide themselves. Fusion does that just as a matter to because it assumes you're going to be working with the bodies. So I'm going to select both of these, E key to extrude. Going to drag it out. We want it to be cut, but I want it to be symmetric. It's going to cut both sides, and now we're starting to get something that looks a little bit more like a thread. Now, the one thing that is different between this thread and our homemade thread, you'll notice, is that it on the end of this thread it tapers in nicely back to the body, where our thread's not really doing that as well. There's a number of things that you could do to try and reconcile this. We could go up here and we could do a chamfer on this edge and just kind of bring it up as close as we can get. So we could go like 1.7, let's see, 1.8, let's do 1.7. This is where sometimes in Fusion you can get like really funny little values that are closer. So that's a little bit better. And you could even do it one more time if you really wanted to make it even a little bit more smoother, so that when you're screwing this in, it has a little bit more of a progression for that thread up there. So I'm just going to leave this as it is. You get the idea. You could finesse that more. All right, so now let's work on the other piece. So this is our male, and now let's work on the female. So we're going to turn back on our base piece, and the first thing we're going to do is we're going to go up to the combine, which is our Boolean operation, and we're going to change this to cut. Our target body is the bottom, and our, I'm sorry, let me rephrase here. The tool body is the top, and the target body is the bottom, and we want to keep tools, because otherwise what that'll do is it'll remove the piece you used to make the cut. And so there we go. So you can clearly see we've got the two different pieces, but our tolerances obviously are right on top of each other. So let's do this. Let's turn off the top, and we'll use the press pull, and I'm going to select the, now this doesn't have a whole lot of threads on it, and if it had a lot more, Fusion will know to select the whole coil all the way up, but in this case I need to manually select some of these parts and pieces. Oops, this is kind of getting hung up on me. So first of all, let's select that, and we'll do press pull, and let's go minus 0.14. And if we turn back on our body, you can see, okay, we've got a good spacing there. And then the reason I'm doing this separately is sometimes you want these values to not be identical, but you can totally do this at the same time if you wanted to on the same press pull action. So we'll do minus 0.14. Whoops, that's not the right value. We want minus 0.14. And let's turn back on. So here we've got our coil-based thread. And let's go over a couple of the, what I would call some of the advantages of doing it this route. And disregard down here that, you know, it appears that our tolerance is not working in this bottom left corner, and the only reason why it looks that way is because that's actually where the butt or the terminal, the end of the thread is butting up against the cavity, which you can see. Sorry, I'm trying to turn on the right body here. Which is another piece to take note of here. The one on the left, you'll notice, has got threads fully through it. So you could essentially screw in something and make it go completely through it. Whereas the one that we made with the coil, the top is totally fine, but the bottom has this terminal on it. So if we wanted to make, you know, let's say this was our nut, the way that we kind of used our Boolean, we'd probably want to move this nut up a little bit so that it wouldn't be hitting this terminal piece on the bottom. And then our cutout would work totally fine. Or, you know, you could not use the Boolean method and just simply do another coil on the female piece. But anyways, let's take a look at why using the coil is pretty cool. So if we go back on our timeline, and again, this is what's great about Fusion 360 is it's parametric, meaning you can go back in time. Let's say that we wanted to change the gap in our coils here. So I'm going to show you something, and it's going to result in an error. I'm going to change this to 4, and I'm going to hit the enter key. And you notice that we got all these errors. And that's because what happened right there, when I made this change to this coil, let me open it up here. At this stage in our timeline, remember our two objects are basically on top of each other, and this operation is set to join, and we want that because we want the coil to join with this cylindrical body, but we don't want it to join with, let's call it our nut or the female part on the bottom. So what we need to do is we need to temporarily hide, when we make this change, that bottom piece. So now let's do this again. Let's go back. We're going to change this from revolutions to 4. And now I'm going to turn that body back on, and look at that, it updated itself. So this is what's really cool about using this coil method is you can easily make changes to the initial coil and it will update downstream. So for another example, I'm just going to scrub here back to where we did this. I'm going to go back a little farther. Where we did this, you know, it was a fillet, and I'm not crazy about the fillet. For 3D printing, I'd prefer it to just be a hard edge. So I'm going to delete this. And what's going to happen is it's going to tell us like, hey, some features in your timeline depend on this. So after I've deleted that, if I scrub forward, you'll notice it did break some things, but that's okay. We're going to fix that. So back here, right after we've done our coil, instead this time, let's use a chamfer. So we're going to do a chamfer, and we'll do 0.2. And that, generally speaking, is a better method, in my opinion, because it creates a cleaner edge for the 3D print, and thus you can create a cleaner gap than using a fillet. Because anytime you use a fillet, it's going to try and, you know, draw those layers as it's bending around the edge, and the resolution, as many of you have probably experienced when you're creating a round surface, you have to kind of vary the resolution sometimes to get it to actually be clean. And we don't got to worry about it with this, and it doesn't matter. Like, this is definitely the way to go. So let's fix some of the stuff that kind of broke on us here. Okay, so our Boolean is still totally fine, and one of the offset faces are totally cool, but the reason the other offset face broke, which makes sense, is because we basically just changed it. So let's fix this. So what we'll do here is we're going to turn off the, and I should have named these things, apologies. We're going to tinkering around here. Okay, we're going to turn off our screw, and now we're going to do some offsets. So I'm going to select those two, and then we're going to go up to modify offset face, and I think we had used minus 0.13. And then if we turn it back on here, there we go. And you'll notice that it made a point. And again, this is totally okay. You could leave it as it is. But if you really wanted to kind of match up, what you could do is you could just do a chamfer again. And we can just select that edge, chamfer, and we're going to chamfer this. I think it was 0.2. Yeah, there we go. And there we have it. So now we've set this up as kind of a rectangular. So one more thing here. Let's just do a quick measurement, and obviously you can tell the gap here between, and there's terminology for these threads, and I should know it. I don't, but this, for example, this upper piece, this lower piece, this piece that I'm selecting right now that is like the outermost part. These all have names, like thread anatomy, if you will, and I'm not a thread anatomy expert, but let's inspect this. So let's grab the upper. And let's grab the lower here, and let's see. the distance, yeah, 0.13, which is correct. But if we grab, and I'm going to clear this, if we grab that right here, and this one, that is actually 0.26. And it's just because the offsets are not, I don't know how to say this, they're not linear, they're not the same. And it's because of the angle and the curvature of the outermost pieces. So if we really wanted this to be accurate, we'd probably chamfer this more like, let's try like 0.3. If you wanted to get a completely, even tolerance, which doesn't really matter, to be honest with you. What's most important is the top edge and the bottom edge, and this outer piece, as long as there's a significant gap, will be fine. And let's turn off our analysis, and there we go.
All right, so let's take a look at these. I 3D printed 3 different variants. Let's start with, you can see here, this is our custom made, if you will, thread. And what's interesting is, as I noted in the, I didn't say it verbally, but there was a caption in the video that I was saying the tolerances seem to depend on the size of the objects. I know in the past I've printed some pretty large, let's say like typographic LED signs that use inserts that slip within a frame, and I've gotten away easily with 0.1, 0.12, but those are pretty large objects. These being super small, 0.12, this wouldn't even move. Way too tight. And so I had to crank up the tolerance to around 3 for something like this. And this was printed on a bamboo. The same with, here's just kind of the out of the box fusion thread. It threads on just fine, works great. And then I printed out a larger model just for fun. So this one's pretty big, as you can tell. And this, I only needed, I think it was 0.2, or maybe it was 0.18, but it was much less of a tolerance than was required for these little guys right here. So just something to be aware of when you're making threaded objects, that the tolerances, seem to vary a little bit depending on the object size.
Hopefully this was helpful. Go in and play with some nuts and bolts and stuff and print them out. It's kind of fun. When you have a functional piece that you can kind of thread together, it's a good time. Happy printing.